Now that we know what a logarithm is and how it works, let's look at what a graph of the logarithmic function looks like. And that's what I have up here. So I wanted to point you to one of the pages in your textbook. It's on page 454, and hopefully you can see my cursor as it's moving around here. So it points out here kind of what we've talked about already, that a logarithmic function and an exponential function, they're inverses of each other. So think about what that means again. Inverses, the x and the y switch. So this red line here is the exponential function 10 to the x power. And we've graphed these before. We know that exponential functions, we have the asymptote, because in this case, our function is never going to cross the x-axis, it's never going to hit the x-axis. That red line, my red function, is approaching the x-axis, but not actually going to hit. Well, if I flip some of my points on here around, flip my x and my y, 0.01 becomes 1, 0. 0.110 becomes 10, 1. This is giving me the idea of what the graph y equals the log of x would look like, because again, they're inverses, the x and the y flip. We'll notice here too that my function, log of x, does cross the x-axis. But, oh, look here. That blue function, it's not crossing the y-axis. So hopefully that kind of makes sense too. Being inverses, the x and the y flip. So in exponential functions, we have a horizontal asymptote. In logarithmic functions, we have a vertical asymptote, the y-axis in this case. Okay, let's do some examples, or let's do an example of graphing and kind of go through the process of how we can actually graph. So let's graph the function y equals the log base 2 of x. And then we also are going to describe the domain and range. The y-intercept, and also identify the asymptote. Well, in order to graph a log function, it's easier to think about what this means. This really means 2 to the y power equals x. Remember, the base for your log is the base for your exponent. 2, jump across the equal sign to the y power equals x. Well, normally, when we graph something, if we wanted to make a table of values, we pick the x values. When I have something like this, though, do you think it's easier to pick x? Think 2 to what power gives me an x value? Or do you think it's easier to pick the y's? 2 to the first power, 2 to the second power, 2 to the third power, and figure out what x is there. Well, personally, I think that's a lot easier. Let's pick our y values, and that'll give us a good picture of what our graph will look like. So, with exponential functions, to start off, we picked -2, -1, 0, 1, and 2 for x. Well, let's pick those values for y now. Okay. 2 to the -2nd power is 1 over 2 squared, so 1/4. 2 to the -1st power is 1/2. 2 to the 0 power is 1. 2 to the second, or 2 to the first power is 2. 2 to the second power is 4. Okay. Now the reason I can do this is because 2 to the y power equals x. That's what our log means. That's what log base 2 of x equals y means. I really haven't changed anything. I just rewrote a different way. All right, so here's my table of values. Let's graph, and I don't actually have a piece of graph paper here with me. Which I can't believe. I usually have a stack of graph paper sitting at home. But now I can plot these points like normal x and y. 1/4, -2, 1/2, -1, 1, 0, 2, 1, 4, 2. Connect my dots and remember too that your graph is going to keep going both directions. And similar to our exponential functions again, we're going to get closer and closer to the y-axis, but we're never actually going to hit. Think about if I had -500 as a y value, for example. -500. I'd have 1 over 2 to the 500th power, which is a really small number, but it's still more than 0. So I have that asymptote. Okay, let's look at domain here. My domain my x values. I can't have any negative x values for sure. Can x equal 0? Well, is our graph going to hit the y-axis? No. So our domain is really just x is greater than 0. As for our range, well, our graph is going to go down forever, and it'll go up forever. So our range is all real numbers. The y-intercept, are we ever going to hit the y-axis? No. So no y-intercept. And then the asymptote. That's our line that our graph is approaching, but not actually going to touch. Well, on the top here, my y values are going to keep getting bigger and bigger. My x values will keep going to the right. On this side is where we can write equations of vertical lines in the form x equals some number. And the y-axis is the line x equals 0. So we've answered all of our questions here. Domain x is greater than 0, range is all real numbers. Hopefully you're kind of noticing some similarities, or you're kind of thinking of some similarities with our domain and range here with our exponential function. Exponential functions, the domain is all real numbers. The range is greater than 0. So flip-flopped here, since they're inverses of